Now you should hear me. The fuck? The microphone was not added to the scene. Sorry for that. I guess we start over. Thanks, Steve, for pointing that out. And I did not see it. Um, Not sure what happened there. Yeah, so not sure what you heard now, but the plan is basically this board out, this board in. There's a CAN bus adapter up here that also goes out, and there's a lot of random stuff set up on this machine. For example, this filament runout sensor here with the switch. We will remove that for now, I think. So I want to simplify the entire setup a bit. It's like super messy. We added like some random stuff here. So yeah, I just want to simplify a lot on that machine. Steve, let me know if now the sound is all good. So, but yeah, I would just say let's just start with removing stuff and just dump it in here. Let's just get started with the CAN bus board up here. I'm also thinking of replacing the toolhead board cable. Let's see what the status there is. And the electronics we remove here will go one-to-one into the Satsuma 180. We have sound now, but you don't know what better with or without. Well, you have to live with the sound now. Let's see. We'll figure out later what cable is what. So that's the toolhead cable. I'm just quickly flipping it over here. And we have some Wago clamps. So let me also open this up. This for sure, we don't need any more of this cable here, because we will only have one board. Hey, you, can you lift that? And I think we also should clean this fan here because that is super dirty. Okay, then, yeah, we don't need these power cables here. Oh, we do. We still need those. I just realized because the board, like, it has a CAN bus header here, but this is only CAN high and low. So we still need to basically provide the 24 volts separately. So these cables need to stay. Then what else do we have here? So we have the white cable here. Oh, this is the switch that already goes to the Pi, I think, so that we can leave. Oh, there's the filament runout sensor. It still goes here. Okay. So this is the filament runout sensor. And this is RGB LED here. Then we have more RGB LED here. So we will lose some RGB LED for now. That is for sure. Because we only have one header here, I think, for LEDs. We need to later check. And I also remember that there was something off with the RGB on this board. I never tried it, but Ravenkeeper tried and he was not successful. Okay, let me just unplug everything here for now. And then we will figure out step by step what goes where. And then, yeah, next year, there will be like a full rebuild of this system, of this printer. So we're gonna completely like strip it down and start over with a lot more mods, a lot more fun. Hi, Mr. DDSI. Welcome to the stream. Okay, here we go. Oh, I need my screwdriver. Hi, Leo. Welcome. Nothing happened. We just this board will go into the Satusma. And in here we will get a smaller board. And the small board is a Mellowfly Micro 4. It has CAN bus inbuilt already, so we can also remove the CAN bus adapter. So it's just a bit of optimization. So nothing wrong with this one. It's just purely some shuffling. And I think this one here will be quite painful to remove. Let's see if I can. Yeah. Twisting is always easier with these VHP tapes. No, but this one has been here for a while and it's a bit cooked. Baked in. No, that will be fun to remove here. You know, fully remove it, but like the bulk of it should come off, I think. Yeah, I call it good enough. Okay, lots of cables. Let's see what goes where. So we have these, which is the yellow one is the RGB-LD. And if you remember, and I remember, the RGB-LD on the system are not working. There's something wrong, and we never figure out what. Now with the new board, we have a lot less RGB. Let's actually quickly open the documentation of this bad boy. So technically, you can have all the RGB in one plug. WD-40 works well. Let's try WD-40. I think I do have here. And I also have VHP tape, which we need in a second. Let me quickly get some kitchen towel. 1 second. Okay, let's see if that works. So I'll try to make the biggest mess possible here. I'll just let it sit for like a couple seconds. It's for sure less sticky now, but I'm not sure if it removes it. Acetone I don't have. Acetone I don't have to hand at the moment. We can try alcohol. I mean, it kind of does remove. Yeah, it does peel off. Oh yeah, I call that. I call it good enough. It's not sticky anymore. That's the important part. Okay. Let's check the documentation. And I remember this was painful. Because we didn't find it, and there was like very confusing documentation. I remember that. But here, for example, it doesn't say anything about the Micro 4. Oh, so here we don't get Micro 4. We got the documentation from some Chinese webpage. I remember that. These are all quite big boards. E3, super, super, super. It's all purchase links. I mean, this is... Ah, here. Micro 4. Metalclipper.cn. Exactly, this is the weird Chinese webpage. I remember that. Yes. So this is the board. So we have one RGB port here. We have fans. Some general purpose pins here. So these we can also use for RGB. It's just like we can't use the... I mean, technically this one. Because we need to check. I think some of our LEDs are 24 volts as well. We don't have 5-volt LEDs only here. But I think the RGB port we can just use for the front of the bed for the inbuilt RGB, because like we have one RGB on the front. And then we have this one. This one is like the underglow here. So this is another one. And then what are you? Oh, this one is the servo. Yeah, we also have the servo, of course. Hey, that will be fun. Then we have a Z end stop here. This one powers the Pi. Oh, I also forgot about that. I also forgot about that. At the moment, we power the Pi from that machine, from the thing here. So then we have to add a buck converter. Oh yeah, this one is the LED. This one is the LED I was looking for. Okay, but just like from a layout perspective, I wonder whether we should just like remove a bit of the cables, just to get a little bit more. clarity here, because right now I'm a bit confused. Like not confused, but overwhelmed. So the motors are here on this side. That would be the same. 1 second, I have to grab my cat. He has this new trick. Whenever he wants attention, he jumps on the kitchen counter, which I don't like. Yeah, let's get some stuff out here first. I think it's easier to add it step by step. So everything non-essential, let's remove that. So this is the LED wire, which is non-functional anyways at the moment. So let's remove that. This one is the other side of the LED. Then we have this red one here, which is the power for the LED. And this black one, which is ground for the LED. Yeah, I kind of want to completely remove this cable, to be honest. Because this is annoying. It's like a V and it's like intermingled with like other cables. Let's just, we have to recrimp that. I accept I have to recrimp that. So use laser plug for pipe. Yeah, the laser plug though, if you look at the pin out, the laser port provides VCC. It doesn't provide 5 volt, so that would not end well. The laser port on the SKR Pico provides 5 volts. So that is a difference we need to be aware of. You were sleeping the entire afternoon, and now you're active. Very nice. Let me also maybe grab, I think it's in here. Yeah. Let me grab a bit of tape. And then the cables we don't need, I'll just tape them here for now, that they don't fly around the entire time. Then we have 3 cables here. Check. Then, yeah, so this is the power. This definitely will not work like this. And there's just the yellow one is the servo for the wheel patch. Yeah, so I think this one we also might have to extend later on because we cut that quite short. But let me remove this one here. This is the servo for the brush. Just put this here between the belts. That is out of the way. Okay, and then we have this pi power, which let's put this over here. So with this one, let's see what we do. I don't think the metal fly can provide enough current to power the pi. Then we have these two here. Let's actually add the Wagons back. Then we have those kind of like out of the way. Okay. Then what do we have here? So this is a. I don't want to have this Bowden tube out of the way. This Bowden tube is not helpful. I don't think I can get this out of here easily. Do I have to take off the bottom? Seems like it. Oh yeah, and that's the LED for the underglow. Okay. Now I should be able to remove this for now. Step by step. Then what do we have here? Oh, that's the Nevermore. So this is the Nevermore, okay. What do we have here? Oh, this is the small fan here. And then we have, this is a filament sensor that I don't use because it's not reliable. I might just remove that. Then what do we have here? That's the bad thermistor. Hey, you. You're not feeling like sleeping, right? So, and then we have the motors. And then here we have the 24-volt in and the heater bed. Okay, cool. That's kind of sorted now, I think. So my plan would now be to place this one relatively close to the bottom here. Something like this. And then we have enough space here maybe to have a buck converter later on. Ideally, I would also just have placed this like this and the buck converter under. That would also, I mean, if I would have planned for a buck converter, I would have added it under here that we can stack it up on top. But there's enough space to put it next to each other. We can also technically move it closer here and then put the buck converter here to the sides. Just have like a bit more space. There are these screws. I kind of want to put it over the screws, but the VHP I have here is only 1 millimeter, so it's quite thin. You see, I also have thicker VHP tape with 2 millimeter. Then we can put it in here, and that will be fine. Oh, Mr. Design, I missed your message. I don't know if the Mayo 5 back converter will handle the Pine RGB. It might. Depends on the RGB amount. But my concern is also stability, right? If the Pi has fluctuating input voltage, like it's always a bit of a pain. So I think it's better to just play it safe. Use an external back. Um, And actually, I want to place it quite low. So let me quickly, before I put this down, insert the cables here. So the outermost one is 24 volt in. So this is these two. And then that has no polarity in this case. That's the next two. And then my plan actually, I'm kind of considering if we just remove the LEDs here on the side about the LEDs because they're not working. And I know that I don't use, let me see how low I can place this. Let's do it like this. I think this is good. I'm not sure if the WD-40 is now preventing the VHP from sticking. I think it does. Yeah, okay, I need to get alcohol, I think. Let me quickly grab alcohol, 1 second. The only thing with alcohol and acrylic sheets like this is you need to be a bit quick and you shouldn't let it sit. Otherwise, you might damage the acrylic. Now the sticker is almost gone. Okay, let's try again if this now sticks. Yeah, no, still not. Weird. Maybe the VHP is now broken from the... Yeah, it doesn't stick. I have to replace at least this one here. Let me quickly replace both of them. And let me also quickly remove the board from this mount, because then I can properly push it down. I love VHP tape. Okay, let's try this again. So somewhere... Yeah, now it sticks properly how it's supposed to. Okay. Let's see if we get the motors in. I mean, there's not really like an order of these motors, so I'll just plug them in and we'll figure it out later in the config. This one is a bit shorter. Let's put this here. Okay. Then this is the bad RGB that will go the next to the USB-C here. Then we have the bad thermistor. That goes now to the bottom above the bed. So that goes here. Then this is the controller fan. So fans, we have two here, which is exactly what we need, right? So we have the controller fan, which goes here, for example. And then we have the Nevermore, which, shall we recrimp this? This cable's a bit, I don't like this cable. I think we should recrimp this a bit shorter. Let's do it. Something like this. And then we can twist this properly together. Okay. That's we will most likely have to do a fair bit of crimping, just like because the ports don't align properly. Oh, I'm an idiot. While energetically sniffing the cable, I cut myself. Amazing. That is a classic me. Let's put this over here. Crimping. I use 24 volt, 124 volt daylight in the two sides and run them from the hot and output. Steve, this is exactly what I want to do. That's why I'm kind of like thinking like, I think I removed them because I don't need RGB LEDs there. I know when I did that, everything was RGB, but I don't use it. It doesn't have to be RGB. I don't need RGB. Same on the 2.4 here, right? I don't have RGB bad LEDs. I just have 24 volt daylight. And also there, I think we run it from the hot end plug. So yeah, that's exactly what I will do. The problem is I don't have the 24-volt LEDs at the moment. And even if I would have them, I think it's best to focus on the main board in this stream. Like, if I remove the bad LEDs, I'm not losing anything because they're not working at the moment anyways. So I think for this stream, I'll just remove them, and then we most likely tackle that when we rebuild the machine. It would have been smart. Let me first quickly remove the pins from this housing, and we can reuse that. Try to get a somewhat even twist in here. Long to do this for rebuild. Yeah, like my plan is actually just literally just stripping it down to the ground. I'm just double checking that the fan pinout is the same. VCC is on the inside. That is correct. So VCC is on the inside. So this goes here. Let me also push this under the cables here. Now this is a bit more orderly. It's such a like pointless classic me injury. Most cables in here are kind of sorted, right? That looks quite good. Oh no, we have these here. What do we have here? Z end stop. Where does Z end stop go? Did you check the VCC of the RGB port? The VCC of the RGB port is 5 volts. It's I did check that. So you see here, you have the laser and the RGB port, and the RGB is 5 volt and the laser is VCC. So that should work out. So we have 2 end stops here. And they are most likely, exactly, they are cross-wired with the diag pins. So we need to be a bit careful here. So we have like these 4 multi-purpose GPIO here, but they are cross-wired with the diag pins here. So you see the diag pin of this stepper is 12, which is the same as this one. So we need to see which ones we can actually use there. So and also how we wire this at the moment, this is like, this just causes a short. And yeah, so we need to repin those. But then also, which one do we need to use? So at the moment, we use the top 2 motors and the bottom one. The top 2 will have sensorless homing. That means that GPIO 13 and 14 are blocked, which is the center 2 here. Let me do the following. Just for our visualization, I will block these 2 with like empty housings here. So these two are blocked from the diag pins of these two. That means we have two left, which is pretty good because this is exactly what we need. The only thing we need to do now is we need to move the middle pin here to the outside. Because these two pins are 24 volt and ground. So if we plug it in like this, we bridge 24 to ground and have a short. We don't want shorts. So no, can you come out? Doesn't feel like coming out here. This goes here. Here we do the same swap. There's yeah, wait. Where did you plug your A stepper? The Z stepper is this one here. So this blocks GPIO 12. No, that's a lie. We need to remove the jumper here actually. The Z stepper is free, so GPIO. This stepper has GPIO 12, and this is 15. And 12 is this plug here, and 15 is this plug here. The only thing that I now see, and that's a bit iffy, is if you check here, this pin is VCC, whereas the others are 5 volt. We cannot connect these two, so we need to do pull, like a pull down here to ground. So when I do this cable, we need to remove the white one and put it to the other side. Sure, the SKR RGB pinout is different than the microphone. Are you sure? I kind of blindly plugged it in. Oh yeah, you're right. We need to swap the 5 volt and ground. Let me unplug that I don't forget. And here we said we need to swap the white one over. I haven't quickly fixed the lid nose, and then this goes to the other side. Yeah, so basically now the VCC, the 24 volt is free. And we don't grill our microcontroller, which is appreciated. Okay. Then here, Steve pointed out we need to change something. So the ground one is next to the Oh, it's actually completely different. Thank you, Steve. Let's just remove all three. Oh, I think I destroyed this pin. Yeah, this is gone. Hey, okay. We have to recrimp that. Yeah, I pushed the nose through, so we have to recrimp. Let me recrimp all three. So these are significantly harder to crimp than the silicone cable. Because on the silicone cable, it's very easy because the casing of the cable is very squishy. Like it's very easy to like squeeze the crimp a bit and it stays in place. With these, it's like very hard casing, and then like it's very hard for these like little things to stay in place. So usually what I do is I put them on, I hold them with my finger, and then I just squeeze them a bit with the pliers here, just that they stay in place and don't fall off. And then I go in with the crimping pliers and crimp them fully. And that's a lot easier if you don't have to squeeze very hard for them to stay on. Okay, here we go. You don't take note of your wiring like Fan Zero Nevermore. Wires will be hard to trace in a caption. We will try it out. I know this is a fan. This one is a fan. There will be try and error. So 5 volt is in the center. Let's start with this red 5 volt center. Then we plug this in like this, and then ground is on the side of the USB. And the signal is then on the outside. Cool. Then let me see, where else can we plug in stuff? So what we still need to do, so I'll just remove these LDs, so these will be out. Then we need to do the canvas cable, of course. Then we need the servo motor here. So there is technically this BL touch port down here, which would be perfect for that. The laser port we can't use. Because this is VCC, we need 5 volt. So pretty much the only thing that is left we could use would be the wheel touch. So we need to run the servo wire all the way down here. Which would be quite okay for these two, but the yellow cable we cut quite a lot shorter, so this will not work. So we need to extend the yellow cable. But what we can already do is we can try to salvage these pins here. And then we need 5. So then 5 volts goes here. And ground goes next to it. This is just long enough to reach here. That's quite nice. So we just have to fix the yellow cable, and then we are also ready with that. How do we do that? I think the easiest is just to solder. Oh, well, that did not work out. Why did you not? Interesting. Oh, no, nice. Now I put in the wrong one. Okay, let's try this again. So this goes in the second. And this goes in there's side 1 from this side. I think I just didn't push them properly in. Okay. If you can see correctly on my phone, GBL19 is the servo pin. Yes, exactly. This was what I wanted to use. GBL19 is here in the center. That's the one I wanted to use. We just have to extend this wire here. We can use yellow from the LEDs. Yeah, let's just use one of these yellow LED wires here. Then let's do the following now. Let's just remove the LEDs. Then we get some wire. I think to remove those, we have to remove the side panels. I don't think we can. This was always like, it works. Ha! What's that? Oh, no, these are smart. They are 24 volt though. But these are the smart, the addressable LED. Let me just pull it out. Oh, I see why it's stuck. There's I soldered a bit of cable. There's now stuck between the. Okay, that was the most difficult way to do this. Okay, here we go. I will keep these LD bars. We might reuse them. LDs I'll just kick out because we cut the side here. It's like we will use the yellow cable though, we said. So let's just get this a little bit out of the printer. And then let's just solder that. Before we solder it, let me quickly clean up a little bit that we have a bit more space. Get some IPA for a cut. Yeah, later. That will survive. But it was like classic me, right? Like I was like holding the cable, like how long? And I was like, and it was a bit too energetic. We have even yellow heat shrink. Okay, so I'm not gonna be able to remove that. I mean, I would be able to remove the servo, of course, but this would be quite painful. So we solder inside the printer, basically. Let's put heat shrink over. And then we can cut it to length. I think that was the only time we have to solder. Yeah, you know, this is the silicone cable I usually use. It's like very easy to like just squeeze it a bit and it will just stay where it's supposed to stay. It's what I said, and then I screwed up. Okay. That's the next one. Then I think the only cable for this board left is the CAN bus cable. And here, two options. We leave the cable as is at the moment. I'm not a fan of that. The other option is I do have a proper CAN bus cable here that I actually pre-crimped already at some point. So I would use this one to replace this flimsy cable here. Because this is not a proper CAN cable. This is like just a four wire cable. Technically, this is fine, right? So for like very short runs like this, it doesn't really matter. You don't have to have the twisted pair. I mean, technically it's better, of course, but I don't think it creates problems usually. The only time when it creates problem is like if you have it parallel with motor wires, for example. Then you really need a twisted pair, but that's not the case here, right? So hi there, Raj. Happy Friday. Uh, we need some, let's do it later. And I'll just cut plenty. That's enough for like at least another V0. Most likely we'll use the rest for the Satusma because we have to have the same cable. I hope this is okay to go through this like the cutout I have here. I mean, it's kind of just fits. Let's see how long this needs to be. Let's maybe do it like this. That seems to be like a good length. Maybe I can do a tad shorter. But we don't want it to pull on the tool head either. We had that before. That also is not good. Let's do it like this. Let's get some cable ties as strain relief. And here, I think this is already good enough as it is, but let's put it from this side. So this just clamps the cable on both ends, that like the load is not transferred to the plug. My 4-wire silicone wires last longer than the pre-made CAN wires. Yeah. I also did not have any issues with these. The only time I had problem is when you like run them in parallel with the board. And I think like on a 2.4 something, I would not do that because it's quite a long stretch. But like seriously for V0 and like this 20 centimeter cable here, it doesn't really matter. Okay, the other thing I did not consider now, before like putting this in there, maybe we should have like removed the isolation because the ground and 24-volt wires need to go here. Let me quickly remove that again. I don't want to damage the cable. I should have though marked at which point we can remove it. Let me see. Uh-oh. The inspector is coming. Don't play with your luck. There is a lot of electromagnetic interference around your house. Yeah, that is true. So this is pretty much the length we wanted, right? Like this. Okay. So I'll make a teeny tiny cut where we need to strip the isolation from, which would be here. I always hate doing that. Yeah, let me. This was too optimistic. I kind of figured this would not work. Oh, come on. Here we go. So just pull enough cable through here that the zip tie sits on the black isolation. Okay. Then we have our twisted pair that we can do in a second. We have the 24-volt cable, which goes here. Nope. And then we have our black cable. AKA ground, that goes here. I think we moved a tiny bit too much isolation now. Perfect. So this is good. There's no tension in the front. It will touch the back here a bit in the back position, but that doesn't matter. And this is one of the small connectors we have to crimp. So that will be fun. Steve, can you convert to three-way Wago to also get power for the buck converter? We can. But if we do so, we can't use the Vago clips here because these are only two. But technically, you can use just some VHB tape to tape the Vagos down. I think that's quite a good idea. Let me quickly. My crimping mojo is not very good today. Okay. Quickly check, where are they hiding? Wait, I had one of these connectors flying around here. Ah, here. Let's reuse this one. Not a question. What is can high, and what is can low? Let me see. So we have a EBB 36. White is can low. White is can low. Low is on the side of the USB. We said white, yes. So can high is yellow in general. Steve, that is good information. But I guarantee you that when I crimped this on the other side, I didn't pay attention. But yes, we accidentally got it right here. The only thing I now see, there's a tiny cut or damage on the isolation of the can low. So potentially we have to recrimp that tad shorter. So if we have can issues, that might be the issue, the little cut here. Okay. Then if I didn't forget anything, the last thing is the back converter. I think everything else has its place again. Minus the LEDs we removed. Okay, let's check for the Wago. I have a 3-pin here. I mean, we can kind of like VHB tape this one here and this one here. That works. That works. And then yeah, the buck converter I would just place here. Oh, the USB cable. Let's do that first. Because then we see where the USB cable blocks some stuff. USB is always the wrong way. Okay, so we don't have this much space here left after the USB cable is placed. I mean, still enough. Oh, and also, I think I will use one of these like mini buck converters I have, not one of the big ones. Okay, then let's do the Vagos here. I think Steve's idea is excellent. Quickly grab another Vago. So it's a bit difficult, but will work. Yep, that's excellent idea, Steve. Thank you. So, oh, oh, oh no, this is the LED we used before, 24-volt with RGB. Yeah, but it's not what I was looking for. I was looking for buck converters, which is in one of these. Ah, yeah. So I have these. They're quite nice. I have actually a couple different ones. So these are standard ones. They're adjustable, but they're quite big. There are also these smaller ones, but they can only handle like 1 ampere, and then they burn out. These ones are quite nice. I have them in two flavors. So basically, they take whatever voltage up to 30 volts, and they always poop out 5 or 12 volts. And they can handle up to 2 amperes. That's an experiment. I never used them with a Pi. I hope the output voltage is stable. If we get problems, we know why. But the nice thing about this is basically we can we don't have to stick it anywhere. We can just solder it inline here into the cable basically. So we can just do something like this. And this is the outside is here. So we solder this here. And then we use this on the other side. And to solder, I'll do it quite easy. I just stick the cables through and then we'll just melt some solder over the other side. If I manage to do that. Okay. Then I hope I didn't cut the cable not too short. That would be awkward. Let me also solve it a little bit from the other side. Just to prevent any loose strains from like flying around. Now we have this inline here, and I'm just going to use a bit of this like white heat shrink to just shrink this in. And then this is basically just like one cable. Before I do that, I quickly want to see that it works in principle. Yeah, this is quite nice. All the cables up there. Cool. Yeah, technically we can turn it on, right? Everything has its place. Let's do like a quick double check, sanity check. Oh, what's still missing is the annoying cable bottom tube here. I hope we can manage to wiggle this through there. I didn't think of that. Yeah, that works. Perfect. Okay, maybe I'd like a little like clip or something that holds them together. Sweet, sweet. I think also somewhere in here is this cable cover. Oh, quite a packed. Quite packed. But that should all work. Okay. Sanity check. Let me quickly make a bit more space. I'll just clean up stuff that we hopefully don't need anymore. Oh. Yeah. Okay. Now a bit of stuff shuffled. Switch is off. I will already put in the cable. In retrospect, we could have moved this board a little bit more center here. Yeah, but now it sticks. Let's leave it. So I just want to make sure quickly that we don't have any shorts or something. Most other incorrect wiring, we can. So we don't have a short on 24 and ground. That's nice. Don't have a short here. Don't have a short here. Ground is correct. No short here. These two are shorted out. Let me quickly check why. These as well. So these two are bridged, which is GPIO 16 and VCC. That's a bit concerning. Okay, let's assume this is some stuff with the microcontroller. There should be end stops. There shouldn't be. Okay, I assume this is fine. No, yeah, these two are end stops. They shouldn't be. Oh well, if they're triggered, they are. But one is the filament runout sensor. It should definitely not be. Unless they're normally open. Yeah, okay. Ignore me. Yeah, that's fine. Ignore me. These are end stops, and they're currently connected. So that is that. Then what I also quickly do before I power on the Pi, I will unplug this whole thing here. Let's put it just over here. And then we can quickly measure the voltage if this is 5 volts. Before we fry the Pi, you know, let's just. Okay, ready for magic smoke? 3, 2, 1. Looks good. Let's check for DC. That's 5 volts. Power this whole thing off. Be really careful that we don't, if you plug this in wrong, this might not be good. So this is good. And the Pi has power. Nice. Okay. The only thing, we still need to apply the heat shrink here. Before we forget that, normally you should power down the Pi, but let's be rude for a second. So I'll just put this over here. Just quickly remove that. Will be a lot more fun this way. And that's it. Now this just is isolated, and we can have this just nicely inline. I love those, especially for fans, because then you can just have a fan cable with that thing inline like this. Sure, this is properly plugged in. And then I think we can already put this somewhere. This goes here, right? Yep. Okay, now first, before I do that, let's get everything up and running. So, now the fun part, config. I'm curious if the CAN adapter is picked up seamlessly or whether we need to do some extra configuration there. Let's give this a second to boot up. Pi does have power. Let's see how long that takes. Here we go. Ooh, the camera looks good. So I really dislike these Pi cameras. Okay, let's ignore it for now. There's some signal now interfering with the camera, but yeah, that is later problem. Let's first get the printer to print. Let's see. So if I go to printer config and devices. Yes, we have two. Perfect. So we have two CAN bus devices, which is exactly what I want to see. Yeah, we need to flash the MCU. The only thing is I didn't set up my auto flash thingy here yet. So maybe maybe we need to do that now. But yeah, we have two CAN bus devices. That's pretty good. Then let me quickly, I did not set up a terminal. Let me quickly get that rolling. Let me quickly get that rolling. Does that somehow? No. Size-wise, not quite there. 1 second. Let me quickly resize that. Okay, cool. Then, yeah, let's just set up my auto flash because like we have to do that steps now anyways. Then why not just do it in one go, right? Clip auto update. Here it is. So let's follow the instructions. So let me just stay in the terminal because otherwise I will forget to jump back and forth. Then for each of the boards, we go to CD clipper. The problem is we need to quickly figure out which board is which, right? So we need to unplug one board that we get the UUID of the board. Okay, I quick shut down the pipe. I will just unplug the CAN cable. CAN cable is unplugged. So this board now is disconnected. So we only have one board available at the moment. Then we can note down which is which. But yeah, so basically we go to make clean, make menu config. Then we need to quickly configure the board. Firmware compilation, firmware. This is what we need here, right? Well, Flash see if they will communicate as is, and then only Flash is needed to. Yeah, I think it would be nice to have like the same Clipper version on everything. But yeah, we can technically. I know I can unplug the twisted pair live technically, but I play it safe. So this one, the B64, I quickly make a screenshot of that. This one is the main board. So you say I can unplug and plug it live? No, I plugged it in live. Ha! Here you go. Utility of the EV is the same as before. Also, that is correct. So we didn't have to do the stunt at all. So the B64 here is our main board. Then MCU serial. This will become CAN bus. To be honest, this configuration is quite shit. I wonder if it's not smarter. Let me just quickly copy this to like quickly to a text editor here. Let's just start. Let me check if there's a Clipper configuration mellow fly micro 4. We have like a standard. I mean, there's a reference configuration here. I'm not sure if they, I mean, it must be better. It must be better than the one from LDO because this one is horrific. So I just copy in the main sale. The sample config, and then we just go through here. So this one would be CAN bus. The reference config form awards for V0. Yeah, that might be. I will go through it anyways because I have to. Because we also have to add in CAN bus spec and stuff like that. So this is CAN bus UUID. And then we said this one is the B64 here. Then there's temperature sensor for the Micro 4. That's nice. Core XY, max velocity. Let me quickly copy that back. And then I also had a force move here. We want force move. Then the steppers. This is now a bit all over the place, right? So I think we quickly need to figure those out. I will just quickly copy over the homing things. Then this is already configured correctly. Let's quickly check as a cross-reference motherboard wiring. So we are using. Oh, sorry, I'm still in the wrong window. We are using at the moment the top two. So this would be drive one, and one of those is A, one of those is B. So the step GPIO 6 and GPIO 1. So this is okay. Then we have the TMC stepper something here. I don't have TMC auto-tune here yet. Then stepper Y, I keep whatever they have. GPIO 1 is the other one of the top two, so that's correct. That is all okay. I just override these. And I have position max 1, 2, 2. And position end stop 1, 2, 2. Then we have these. Oh, I shouldn't have overwritten all of them. The run current here is quite high. And I run them in stealth choke. Interesting. Okay. I did screw up this one here because I copied everything in. I shouldn't have done that. Yeah. So I shouldn't have copied this one. I will copy this back. Also here I keep 0.5 for now. Do we really have... No, wait. Let me also copy this one here. Something is a bit mixed up here. I will keep the... Yeah, that's fine. Then we have the Z stepper. We will keep whatever they have here. Rotation distance microsteps position max is 120. And then position end stop. This is like this. I will copy back what I had. Then these we will keep run current 0.37. It's very specific and very low. 110, 0 false. Okay. Then extruder we can keep 1 to 1 because this is on the other board. So we keep the extruder. I remove all these stupid commentators. Most of them are just not applicable anymore anyways. Then we have the TMC22 extruder block. Then we have the bed heater. I keep what we have here. I do update the sensor type because this is what we need. Then smooth time, we have 3. Max power, we don't need. Min temp is correct. And then the pit values we remove. Then we have fan control. These fans are on the EBB, so they stay. Again, let me remove these stupid LDO comments, because they are not applicable at all. TMC Auto, yeah. If we add TMC Auto Tune, I will do that. I did not optimize this config at all. Like I didn't touch it for quite a while. That's all fine. Then we have this PCB fan. I will copy this. And then we also have, oh wait, this one here. So I will just use GPO 16, what they have here. This might be the Nevermore, this might be the PCB fan. We need to figure this out. Speaking of Nevermore, where is the Nevermore? Oh, I have a separate Nevermore CFG. Let's not do that though. So Nevermore, we need to still copy over. Filament runout sensor. Let me quickly see. No, I lost my. Yeah, now the weird stuff happens with the LDO config. It's like they spread this stuff all over the place. So here we had 85. Given that it's the same stepper, but we have both on 85. Then we had let's put that on the bottom. Then we also had temperature sensor EVB. MCU we already had. Let's keep the name. Then we have a probe and screw servo bed mesh. Okay, here comes all the probe stuff. It's also copied over. The probe is connected to the EVB, so nothing changes here. Then we do have the servo for the brush, which is connected to a new port. And this is now the GPIO 19. Filament runout sensor is a separate config. We will copy that in here in a second. And then I will keep my save config block on the bottom. Here, like a lot of macros now, we don't want that. We do need to include, though, a couple of files. So we need to include the macros. I'll put this here on top. It should be fine. And then we need the filament runout config and the nevermore config. So let me quickly save this. To be honest, I don't use this. Let's leave this out. And the nevermore is the only thing we then need. This will go to macros. So we only need this fan generic nevermore. Let me quickly copy it out. So this goes to macros. So this will be deleted. Then we go to macros. We have this here. And then in the printer config, we have fan generic nevermore. Now we need to check. So this is GPIO 16. So 17 is the other fan. And then we need to see, potentially need to swap the fans. That's it. Let's fire. The macro for my servo is in the macros file, I think. Okay. It started up without issues, so that's quite a good sign. Yeah, now we have to just work through all the things. Let me just quickly check the fan. So that's, of course, on tool head. Okay, that's not the Nevermore, so these two we need to change. This is a small fan on the back. Okay, let's do that already. So we need to check for GPIO 17 and 18. Fan. So this needs to be 18. Oh, wait. 16 and 17. So these two need to be swapped. Save and restart. Hey, how's everyone doing? Hi there, Jonas. Well, it's doing great. We just started up after redoing the entire config. So that works. Then let's quickly check the heater bed. So I'll just put it to 35. And we should see the temperature rise here, which is not the case. So Clipper will complain in a second. So heater bed is not operational. Oh, it is. It raised. Ah, okay. I was impatient. It goes up. Cool. That works. Then let's do stepper bus. Stepper equals stepper Z. And we have no movement here, so that is not correct. I think we need to swap the stepper config here. Yeah, we need to swap. No, we don't have to. We can also just unplug the cable. That might be easier. Then I have to restart. Let's quickly. Let's quickly check here. So basically, we just need to use the extruder config here. Step your gear pin enable. And then UART is GPIO 9.3. So these 3 pins we replace. And then this is 9.3. Save me stuff. So basically, I just like now use the. So it used the 3rd connector here, and we are on the 4th. I think that's why we didn't see any movement on set. I do another stepper pass for that. Yeah, now it works. The gear pin change direction. That's a good hint. Let me quickly. Let's just do the following, because I'm not sure what direction is correct anyway. I just move the bed up manually a tiny bit. And then what I do is set. The tool head's also in the center, so we say set kinematic position x 60, Y 60, Z 60. Set kinematic position. That should be correct. Yes, set kinematic position. Did I not have the force move in there? I think there needs a force move enabled through. Let's try this again. No? Wait. Clipper config reference force move. Force move. Enable force move. Close. Close. So basically, you need to have this force move, enable force move, in order to have the set kinematic position command. And the set kinematic position command is extremely useful, because now you see it's homed automatically. Homed, it's not perfect or like not correct, of course, but we have the position, so we can now start moving. So I can move that down. Yeah, and the direction is incorrect, so we need to invert that. But X is correct, and Y is correct. So that's pretty dope. So the XY is correct. That's lucky. Then Z, as Mr. Desai said, the deer pin change. Oh wait, it's actually the deer pin change. So this one needs to be inverted, and then I think we are also correct with the bat. Yeah, now it moves down, which is correct. Cool. We have quite a lot of like unknown commands, set LD, set LD, set pin, set LED in the startup. So LD wise, we are not good yet. I think we also didn't configure the LDs at all. The only LED we now configure is the one on the bat. So let's quickly copy it over. Then the question becomes, what pin? Would that be GPIO 11? So now we should have like RGB here. And it does work indeed. Somehow. Oh, it's incorrectly configured. Like the color is not correct. That's odd. That should be the same. So if I do zero, if I do perfect blue, I get something weird green whitish. That's odd. And if I do perfect red, I get also something white greenish. Off also doesn't work. Okay, something is off with the LED for sure. Also, the TMC auto-tune or senseless homing will not work right. Well, senseless homing worked perfectly fine without TMC auto-tune the entire time. So I'll keep it out for now, but it's on definitely on my list to add. But let me quickly, speaking of homing, let's just give this a shot, right? It's not an RGBW LD, like the config I just copied over from the old one. So I think homing just works fine. And so Y still triggered after retract. How did we configure end stop Y? It's also sensor homing. Diag pin should be correct. Did we accidentally plug something in? No. Retract should be 0. Oh, yeah. Yep. This should be 0. You don't retract for sensor homing. That end stop does not work. So we need to check the Z end stop. Jumpers are set. The Z end stop. End stop pin is, this is a pull up GPIO 12. That should match. Maybe we have to invert it. Let me quickly see. So we can query the end stops here. So Z is open. Let me find the Z end stop. Yeah, so Z end stop doesn't work. No matter if I press it or not, it's always open. The end stop is plugged in on the ground and the GPIO 12. So that should be okay if we have a pull up. Where is it? That should be okay, right? We have GPIO 12 with a pull up. And 12 is exactly this pin here, this one. And I have plugged in on these two. 15, no, 15 is the run out. I think. Yeah, let's retry it. It's a good one. Could be 15. And now that is triggered. Let me press the button. Now it's always triggered. No, I think it's the correct one. I think it's 12. No, it's 15. Ha! You're correct, Steve. It's this one. It is the bottom one, which is 15. And here we have it. Oh, then we need to pull down, I think, most likely here. What was the symbol for pull down again? Was like this? That's weird. Um, do I need to plug it in? GPIO 13. Yeah, but I can't use 13. 13 is the diag pin of the driver 1. That's not possible. That doesn't work with the DDSI. Diag pin 13 is for this stepper here. So then that is already taken. It's 15, but I think at the moment I have it plugged in 5 volt and GPIO 15. I think I need to change it to those two pins. Let me quickly do that. I just want to be careful. I don't want to recramp. No, come on. Here you go. Okay, so that is plugged in now in ground. And then here, let's use the pull up again. Okay. Yes. Okay. End stop needs to go to ground and then pull up. Okay. Then now we should be able to fully home the machine. Perfect. That worked. That is a homed V0. We checked also the fans. So the only question mark is this weird RGB problem here. But with the RGB, I want to talk to Raven Keeper because I remember he had with this exact board, he had issues with the RGB. Oh, the servo, yeah. The servo, I forgot about the servo. Let me quickly check the macro. There's some macro. Deploy brush. We have deployed brush. Do we have a stove brush? Servo works. Nevermore works. Um, so the only thing to check, we have like bad light is not valid. This is weird. Bad light should be okay. What did we? Let me quickly check. What is bad light? Oh, I think this is GRB. I think I copied the wrong one. Yep. I think this is why it didn't work. Ah, still the same. Like it just gives like really weird colors. And not in a way that like the configuration is wrong. I will talk to Ravenkeeper about that. I don't want to spend a lot of time on this LED because I know Ravenkeeper had a lot of trouble with this board in LD, and I don't remember anymore what exactly the cost was. I would say let's throw on all the panels again. And then we had a successful heart transplant, basically, right? There should be one. Oh no, no, the holder broke. Like these printed parts keep breaking on me. Now I'm not having the stream with no disasters and quite quickly. Well, what shall we do, Steve? Shall we? What do you want me to break? Shall I short out the mainboard or something? I mean, the RGB LD being a disaster, I'm not sure. Like, I kind of expected that, to be honest, because I know there was something wrong. I mean, most likely I will now need at least 5 hours to get this one screw in here. I only had to say that. Hey, you. Something isn't quite aligned here. Why is that not straight? So the panels are not straight. Like there's no gap here, but like this is like properly fixed. The height here is in the like the screws here and the extrusion, so it's straight. Is the panel on the head not straight? Yeah, there's a bit of a. Not super important, but it would be nice to have this somewhat straight. I think this one needs to be a bit higher. Okay. Now all the dirt falls out. It's nice. Yeah, these LEDs we also didn't connect now, but that is fine. I am not super into LEDs at the moment. That's for the rebuild to like patch up all these LED thingies. Still a messed with catapult. I mean, I think that's something we could do now. Maybe. I'm not sure if I should. Like, I can just end the stream and take the win, right? But yeah, technically we can update Clipper. One second. Cat is doing cat things. He's in his rebel teenage phase. Yep, but let's do that. Let's set up my Clipper auto update. I think that's a good thing to do either way. I would take the easy win. Ah, Steve. Let's try this. So do we already have the Clipper auto update? Yes. Then for each board, we go to CD Clipper, make clean, make menu config. Then we go to the Clipper configuration. Firmware burning. Let's just check what the final configuration here is. So we have enable extra low configuration options. Then we have the RP2040. Then 16 kilobit bootloader. Then we have USB to CAN bridge. Then 4 CAN RX, 5 CAN TX, USB IDs, 10 100,000. GPIO pins to set is GPIO 8. Let's quickly compare. So we have RP2040, 16 kilobyte bootloader. We have USB CAN bus bridge. We have CAN RX, CAN TX. We have 100,000 and GPIO 8. Quit? Yes. Then next step is CP micro 4. Then let's do quickly the other one. Make menu config. Let's quickly check this at esoterical. Then we have the EVV36. We need STM32. Then we need STM32G0B1. Then we need 8 megahertz crystal, 8 kilobyte bootloader. Then we need communication interface is CAN bus PB0, PB1. Then we need 10,000. For some reason, I don't have to support bootloader entry on rapid double and enable status LD. Maybe my clipper is quite old. What clipper are we actually running here? Yeah, we have quite an old clipper running here. Let me update clipper first. Clip update stream not over yet, yeah. Is it the last version with Cambridge? Did you look at Catapult Conf for Clipper? What do you mean by look at Catapult Conf for Clipper? Why do I not see these support bootloader entry? Fuck, I'm looking at the Catapult config. I don't want Catapult, I want Clipper. Ignore me. Looks good. Yes, I look at the Catapult config. Yes. Stupid me. Save configuration. Yes. But let me quickly double check because now I messed up something. So STM32, G0B1, 8 kilobyte bootloader, 8 megahertz crystal, communication interface PB0, PB1, 1000. That's it. Okay. Then we do the CP with EBB36. Then we go to Clipper auto update, and then we run that thing that it creates a configuration. If we now reload our configuration folder, we have a Clipper auto update conf. We don't have Raspberry Pi MCU. Then we need a USB CAN flashing here. So we have micro 4 description, mellow fly micro 4. Then this is the micro 4 config, flash method is catapult. This one we need to quickly find out, and this one, oh, it's bound with Clipper. 1 second. Cat again. Okay. And this we don't need. This we need to quickly check in a second. This needs to be removed. This needs to be removed. EBB 36 toolhead board. EBB 36, and then the canvas. Let's quickly save that. So the micro 4 has this one. And the EBB 36 has this one. Okay. Then we just need to find this one. How do we find that out? We need to quickly put the board into the catapult. Mr. Desai or Steve, do you remember how I get this? So now basically I need to put it into boot mode, right? There was a catapult command for that. So I can... Okay. He's testing his limits. There was some catapult command to get this board into this mode. -R. Catapult GitHub. Let me quickly check the GitHub page here. -R. So we need flash tool. Okay, let's quickly do that. So we need flash tool dash -I can -U. We need the UUID and then -R. So let's quickly grab the UUID. It's this one. Okay, so now we should be in a bootloader. And then this should be an dev serial by ID. Then it would be this one here. Yes. Perfect. Here we go. Shall we clip auto update? That can only go wrong. Here we go. No such device. It didn't find the device, this one here. Oh, because the, yeah, stupid meme. Because the mainboard is in bootloader mode, of course. That can't work. I shut down the can. I don't want to take the back panel off again. Let me just shut down the Pi quickly and power cycle the thing. Normally we could have just pressed the reset button, but you can't have it all, right? Let's see, it's already there. Or start with flashing the mainboard. That would also be an option, but now it's too late. Let's see. Now it looks better. There you go. Let's quickly reboot that because as always, like it has a bit of trouble after that. But now we have fully updated Clipper on all boards are flashed to the latest. Let's see if it comes online. We're gonna take a second to reboot. And then I think we have like quite a successful stream. I bet Steve did not have that on his bingo card. Yeah, I will update all the other things as well. Yes, oh, you will be shortly aware. I will troubleshoot the latest Clipper for you. You want to note down the version? I'm now on 13.0347. Adam, welcome. If it now comes back online at some point, I'm happy. That takes quite long now. Oh, but I see a green LD here. What's the problem now? Let me quickly power cycle the thing. Oh, just in time. That took a second. Yeah, but I see a green RGB LD here now. The fuck? It works. The LD works now. Did I maybe not restart when I changed the config? Because now it works perfectly. Well, I take that as a win. See, Steve, not even that is, you haven't been even granted like a non-working LD. That was, I think, quite successful. That works. Cool. Maybe the firmware restart. Yeah, but I think I did the firmware restart. Maybe I missed it. I mean, I'm not claiming that I did it for sure. So let me do that. But while we do that, I think I will take this win now. Like I think I really like stretched my luck today. Everything works. So if now like the updates break everything, you know, like then it's off stream. um yeah, I'm quite disappointed as well. Like way too smooth. But maybe like, you know, like I beat the curse I had, and now everything moving forward is perfectly smooth. No, but I think it's a very nice upgrade. Like electronics are a lot simplified. What I can do now, so when we rebuild this, I will not mess with this machine a lot more now. When we rebuild this, by the way, why am I like super low here in the camera frame? Like somehow it's like a bit off. When we rebuild this, I will add just like straight 24 volt daylight LEDs here on the side. Like I don't need RGB here. And then for the bottom, what we will do, these two we will just put in parallel. So like the LD here and the one on the bottom, they will always be the same color. Whatever. That works perfectly fine. So because then we don't need any extra boards to like drive LEDs and stuff like that. Like I really want to have like a simple electronic setup here. What is actually, by the way, quite nice, this mainboard has the same hole pattern than the Raspberry Pi. So technically we could also stack them, but not sure if that makes stuff simpler or harder. But yeah, this is it for today. Bad news, next week I'm traveling, so I'm not gonna have a stream next week. We will see each other then in the first weekend in November with some 2.4 action where we do the cartographer. And once that is done, we jump back to the Satusma. What mods are you going to use on the rebuild? I did not look into that yet. There has been no planning yet. I know I want to mod quite a bit, but I am not sure yet what. Well, see you in 2 weeks. Enjoy your 2 weekends until then. Bye.